Adam Walmsley. Adam is currently BIM manager at the consulting firm BG&E. With 12 years of experience in the delivery and documentation of major structural projects, Adam was present when BG&E first began to adopt the digital engineering processes. Over the years, Adam has led many large high-rise and residential projects, and in the last few years has taken his digital engineering experiences across to BG&E's developing bridge and specialist structures team. This involves working on many complex and large civil infrastructure projects and ultimately helping to deliver and implement sound workflows to help achieve BG&E's BIM goals. In this eConcrete presentation, Adam discusses his views on building information modelling and how this process has assisted BG&E in pushing the boundaries in our industry.
Hi everyone, my name is Adam Walmsley and I work for BG&E, who are structural engineers. I've worked at BG&E for 10 years and was there at the start when the term BIM began to be thrown around our office. I've worked in our buildings group and I'm now part of our bridge and specialist structure team which implements BIM processes, and I use what I've learnt during my time with the buildings group and now I'm applying that to the bridge team. In my opinion, it has been the biggest buzzword in our industry for a while now. Some of you may have a thorough understanding of what it means, others maybe not so much, which is why you're watching this presentation today. Seeing as this is the Concrete Institute, I figured I may be able to help your understandings of BIM by drawing some parallels between BIM and everyone's favourite topic here, which is concrete. I know that I'm not telling you guys anything new here, but concrete at its most basic, it's a combination of different materials that results in something that is really useful for the construction industry. Similar to this, BIM can be seen as a combination of materials or disciplines on a project that work together in a digital environment to design, construct, and manage a project more efficiently than we could before. Essentially, this is something that is really useful for the construction industry, just like concrete. The aim of my presentation is to inspire you guys to generate some discussions around BIM moving forward and looking at the way you work and improving that, and ultimately encouraging and driving change, which is what our industry needs. The construction industry is one of the worst performing industries when it comes to digitization and utilizing technology. The graph here shows us where the construction industry sits in relation to other industries and their adoption of technology and digitization. The green is high digitization and the red being low. This is scaled out across a range of areas, but overall we are down the bottom. The other columns cover areas like business processes, digitization of work, and digital spending, i.e. research, development, and implementation. It's 2018, we have so much technology at our fingertips that this has to change. BIM goes a long way to improving this statistic, and by starting to think BIM or think digital, it will help us get off the bottom of that list away from the farmers. So what is BIM? BIM stands for Building Information Modelling, and I'll come back to each of those letters individually in a second. Building Information Modelling is a process or a way of working rather than a physical object that involves the delivery and operation of built assets using well-structured, data-rich, object-oriented digital information. So to summarise that, BIM is a process, and this is probably the most important concept to understand. It is a virtual process that includes all disciplines of a project within a single federated digital model and allows all team members to collaborate and communicate more effectively and efficiently than traditional ways in the past. This is what you can see here in the image on the screen. Every discipline on a project comes together to form the BIM process. It's not just engineering and architecture, it can also be used for site and cost management and facility management after the asset is operational. So to break BIM down a little bit further for you guys, the B is easy to understand, building, basically any asset that we can construct. The I stands for information, and in my opinion this is one of the biggest factors supporting BIM as a whole. The information is what differentiates the model from just dumb 3D geometry. The elements in the model can hold It can hold any data that you think is useful for the entire project's lifecycle. For example, the pole cap on the screen can contain information regarding its concrete strength and its reinforcement. We can also add loading information about the mix design, and other things like that. You could also add information about when it was built, who built it, and were there any issues on site. You can also add site photos to the model, and you can start to see that this model becomes the single point of truth for every aspect of the project, rather than scattered across email chains, reports, drawings, and sketches. The M in BIM stands for modeling. All of this information is captured inside an accurate 3D representation of the built asset and of every aspect across all disciplines. The finished model, full of data about the project, can be handed over to the facility manager or the asset owner, and it can be used to manage the asset into the future. The model can be referred to for future renewals. Say someone wants to put a penetration in the concrete slab, they can find that information in the model rather than having to scour through drawings. In my opinion, the M seems to cause some misconceptions in our industry. The M traditionally stands for modeling, but I think that it should stand for management. So it reads Building Information Management. BIM is the process we use to capture all of this data in the projects that we design, construct, and manage. Essentially, it's really just a big database for everything. So some common misconceptions, as I just mentioned, there are some. The first one would be that BIM is not a technology, but a process. And I think that that's the most important aspect to understand. We don't hand over the BIM when we have finished the project. We might hand over the model, but we adopt the BIM process to deliver the project completely. It's not just software. Just because you may have a version of Revit and Navisworks installed on your computers at work doesn't mean that your project is now doing BIM. You may be able to adopt some BIM processes internally, which is what I will talk about soon, but overall, successful BIM on projects needs the input from all disciplines, not just one discipline or just from one piece of software. It's not just a 3D model with geometry inside of it that is used for visualization. Visualization is a great benefit of BIM, but there's a lot more benefits to it that make up BIM. And it's definitely not just attending a BIM meeting every couple of weeks to watch someone talk about clash detection. So I'm not going to go too deep down the rabbit hole with explanations and graphs about what BIM is, but I do want to touch on a couple of things. In my opinion, change is as good as a holiday, and for BIM to work successfully, we need to change. We need to change from our traditional design processes to one that reflects this graph on the screen. It's easy to say that this is the way it needs to be, but it's much harder to implement this in real life. One important change required for a BIM project to work successfully is adopting what they call a front-loaded design. On the screen you can see the curve number 3 there, and we need to move that curve to where number 4 is. So we're bringing it earlier on in the design phase. I guess the bulk of the work happening in the early design phase rather than in the construction phase, which is how we traditionally deliver projects. The benefit of this is that front-loaded projects reveal potential design problems early, and the necessary coordination among the design team can occur sooner rather than later to resolve these issues. This is in contrast with traditional design workflows using traditional 2D CAD tools, where the opposite's true, and most of the time the drawing time happens during design development and construction documentation. The problem with this traditional workflow is that coordination, resolution, and design changes tend to happen later in the project timeline, which are more costly than making the same changes earlier on in the timeline. Like I said, it's easy to talk about or show on paper, but in the real world, this is proving to be quite difficult. But I'm going to now show you guys a couple of examples of how we've used front loading to good effect, BG&E. Something else I think is important to understand about BIM is that software is an enabler. As I mentioned, BIM is not a specific piece of software. However, software plays a pivotal role in enabling effective BIM processes. As you can see by this image on the screen, there are so many programs out there that we can use to get information into the design authoring software. And when I say authoring software, I mean the software that traditionally produces the drawings from the 3D model. The key to getting most out of BIM in your offices is to encourage your super users of various pieces of software to find ways to work better together with the technology they have. You need to find people that can figure out ways to exchange data between different versions of software rather than resorting to traditional paper markups and exchange of information in that way. Data is important to the BIM process, so you need to be exploiting that. Or you need to find someone or hire someone that can write code where they can create efficiencies for your team of modelers, where they can eliminate the repetitious or tedious tasks that may revolve around a project. And something that's not shown in this example on the screen is Excel. And I think Excel is excellent when it comes to being a piece of BIM software. The project I'm currently working on uses Excel extensively to get our designers updating models and driving geometric changes, which removes a lot of manual data entry and potential double up of effort and cost. So I want to talk a little bit about an analogy. So let's say you have a fantastic concrete mix design. It may be perfect for what it's been intended to do, but on the day there's an issue, perhaps it's too wet, someone on site does a slump test and decides that it's not good enough to be used for that critical transfer beam on a building that's supporting 30 stories above it. Rather than sending back that entire batch, someone has decided that the mix can be used on site, and they end up turning your fantastic mix design into a temporary access path on site or something very basic like that. At the end of the day, they're still getting use out of your mix, and it will benefit from its use when it sets. You can draw similar parallels like this with the BIM process. I think in the perfect world, you'll have a single data-rich federated model developed throughout the design with as-built information added that you can hand over to the asset manager for use as the asset becomes operational. This is the equivalent to your perfect mix design. However, where we are in Australia with our adoption and development of BIM on projects, there may not be strict guidelines in place yet, which is fine because as designers, as structural designers, we can still make BIM work for us internally. So that's essentially saying that even though that concrete wasn't used in the transfer beam, it doesn't mean that it can't be used successfully elsewhere. Things like working smarter with technology, streamlining our design processes, reducing errors, and minimizing risks can still be done for ourselves, not just for our client or for the asset owner at the end of the day. And at BGE, we've implemented many ways to do this. And in most cases, we're using Autodesk's Revit model as the central point of information. So a way we are able to achieve our BIM goals, our internal BIM goals, even when there isn't a strict deliverable on the project, is something you can see on this screen here. We can use the architect's model and we can import their room data into our structural models. We can take this information and we can apply structural parameters to them, such as loading and things like that. And we can send that data out to ETABS or SAFE for floor analysis. And we can bring that data back into the model to help us create slab loading diagrams and use it in schedules and things like that. I've just got a couple of screenshots on the screen that show how that process is working between sending the architectural data out to the engineering software and then bringing it back into the Revit model to create the loading diagrams that you can see on the screen in this last image here. So this project that you can now see on the screen is something where we've really seen the benefits of BIM being used. It's a complex steel bridge which required the modelling of accurate steelwork because the steelwork acts as supports for multiple precast panels, which is what you can see in blue there on the screen. The accuracy of the steelwork set out and the modelling was crucial because the precast panels were placed on top of the steelwork accurately in 3D space on the model. This bridge had some complex horizontal and vertical geometry, so it was important that we modelled this stuff correct the first time, and then we were able to create our 2D documentation from that. We also found out later on in the project that the steel fabricator sort of disregarded all of our 2D documentation and they used the physical model that we sent them as the basis for their pre-cambered steelwork models. And the precast manufacturer also requested the use of our 3D models to assist with constructing all their panels. This next slide here just shows a little bit of a close-up of what I'm talking about. You can see the image down the bottom that's an image of our red structural model, and the green is the steel fabricator's model, where they'll put some bolts and plates and things like that ready to send out for shop detailing. And the image above that, so you can see the blue precast there with the dark red cross members which the precast is sitting on. So it was vital that all those pieces got put together digitally once, because it saved a lot of problems down the track. We've also worked closely with builders to assist them with estimating of things. I guess this is touching on the front-loading idea earlier that I was talking about. So front-loading the project here, it allows our builders to work through and to identify these kind of issues. We can incorporate poor areas into the model, which will result in accurate quantities for concrete and for formwork. We can also add reinforcement rates and concrete strengths to these poor areas to get an even more detailed breakdown of information for them. And we can give them whatever quantities they ask around construction joints, and we can give them steel quantities, or we can give them linear meters of different joints, anything that they like that would really help them estimate the cost of their building in a much quicker way than what you traditionally would do with a scale rule and a red pen. Similar to the estimating that I just showed in that previous slide, we can take things even further for our clients. The model on the screen here, we have we've extracted some data out to Excel, and we've done even further analysis. This project that you can see is a fairly complex steel and composite concrete tower, and the clients asked for as much information from us as possible. So we've generated there's about 20 schedules, I think, that we gave them, and there's a whole range of information that they could see here, such as steel quantities, reinforcement, and the concrete for the actual composite columns. We could give them breakdowns of column sizes, plate thicknesses, steel volumes, reinforcement rates, and concrete volumes. And then the client, or us if we wanted to, we could take this output further, and now with the use of some new software like Microsoft's Power BI, we can run that into that analytical software and start to generate some really nice data visualization graphs to help explain the quantities and things like that that's going on in this project. We're also able to use models to assist us with complex refurbishment type of projects, which is what you can see in the top two images here. The green elements are going to be newly constructed elements, and the red elements are going to be what's demolished. This benefits our design team and the client and our team on site, as it gives an easy visualization of what's going on site and what's about to be done, and what needs to stay and what needs to go. The image below shows you some complex 3D reinforcement, and it's another interesting area that we are benefiting internally at BG&E. So the ability to model complex REO in highly congested areas really ensures us that we can fit the appropriately designed bars and place them where they need to be. Again, I guess doing this once inside the computer before they go out on site, because if they go to site and it doesn't fit, then there's delays and a lot of costs involved with that sort of downtime. So just to wrap up for today, I'd just like to read this quote and talk about it a little bit. So barriers to BIM have been 10% learning a new technology and 90% changing a mindset. Like the image is shown here, adopting effective BIM processes really requires a change in mindset over anything else. You'll hear differing opinions in the industry saying that BIM is more expensive or it's not worth the investment, but it has been proven that by adopting BIM processes, this can result in projects being delivered much faster, cheaper, and ultimately with less risk. As design consultants, we're constantly being asked by our clients more than ever to provide these models that are full of useful data that they can use. Some people will see that as an additional cost, but if you can identify your super users in your company and encourage them to create new, better workflows by using and manipulating the technology that we have on offer now, you'll find that there's no additional cost at all, but you're actually innovating and you are creating cost savings. You can also use technology like we have at BG&E to work closer with your clients, which also builds relationships, and that can become invaluable to both parties, and I don't think that's something that you can put a price on. I think that BIM is here to stay, and in the future it'll be simply the way we operate. I think as the construction industry sort of struggles at the bottom of that list earlier in my presentation in regards to digitization, I think that pushing the use of technology as designers and showing our colleagues and other project collaborators what we are doing will go a long way to changing that statistic. The technology is already here, and the technology is improving every single day, and we just need to start using it. So just to finish off, if I can refer back to our analogy in our concrete mix design and draw another parallel, I've explained in today's presentation that in a perfect world, every consultant we work with on every project will be BIM capable, and every project will come in under budget. It'll be constructed early and efficiently using iPads on site and handed over to the facility managers sooner. But in reality, where the industry is at in Australia, we're still a little way off that. There's certainly companies out there that are doing some great things, but we are in the middle of a complex change, and we can't expect this stuff to happen overnight. Therefore, I think we need to look at our own teams and look at our own internal processes and make changes there, saving ourselves time and money as structural consultants, while also helping out the rest of the project during its future life cycle. Just like concrete, you need all of the individual elements to come together. So you need the rebar, you need the cement, you need the water and the aggregate to form that efficient, stand the test of time product that concrete is. So without one of those elements or a variation to the design, the concrete form will not live up to its expectations under its loading. It might not necessarily fail, but you know as the designer of that concrete that it could be better or it could be more efficient. And BIM is similar. I guess the intent is to get the asset owner a fully coordinated, data-rich information model, which contains everything possibly related to the project, from the initial design through to as-built information with every single discipline, and it will have the input from project stakeholders. If one of those stakeholders can't deliver a rich, data-rich building information model, the project won't fail. Just like the concrete won't fail, it just won't be as efficient as it possibly could be. Fortunately for BIM, the project itself won't necessarily fail if, for example, the MEP guys don't deliver an information model. But unfortunately for concrete, if the Rio isn't delivered to a beam by the time it gets poured, you definitely would not want to be removing that formwork from that beam. So thanks for listening to my presentation today, guys. If you want to get in touch and have a chat with me about anything you've heard today, you can drop me a line at adam.wormsley@bgeng.com. You can get me on LinkedIn as well. And if you'd like to see more about BGE and what we do and the services we offer, you can head to our website at bgeeng.com.